Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about types of concrete, strengths and applications. While all concrete mixes have some common ingredients, namely cement, water, and a mixture of sand and stone, a number of different materials can be utilized to give the resulting concrete different properties. Different types of concrete and their applications. Typically, there are 24 different types of concrete used in the building and construction industry depending on the type of construction. These are discussed below. Plain concrete. It is the simplest kind of concrete that does not require any reinforcement. The most commonly used mix is cement, aggregates, and water in the proportion 1:2:4. The density of this concrete is between 2,200 and 2,500 kilograms cubic meter, whereas its compressive strength is in the range of 200 to 500 kg square centimeters. Usually, plain concrete is used for constructing pavements, footpaths, and buildings in areas that do not require high tensile strength. Normal strength concrete. It is similar to plain concrete as the same ingredients are used in its preparation. There is an initial setting time of around 30 to 90 minutes, depending on the properties of the cement being used and the weather conditions at the site. The strength of this type of concrete is between 10 MPa and 40 MPa. High-strength concrete. It is prepared by decreasing the water-cement ratio to less than 0.35. Such concrete has strength exceeding 40 MPa. Working with high-strength concrete is a significant issue because of its lower level of performance. Rapid strength concrete. As the name suggests, rapid strength concrete acquires its strength within a few hours of its preparation. It ensures quick construction of buildings and roads. One of the most common applications of rapid strength concrete is for repairing roads. High-performance concrete. These types of concrete display a high level of performance. They conform to specific standards such as rapid strength gain, easy placement, high permeability, high durability, life-term mechanical properties, and addressing environmental concerns. Ultra-high performance concrete. Besides the common ingredients used for manufacturing concrete, ultra-high performance concrete requires silica fume, quartz flour, and fine silica sand. One can also use high-range water reducers, steel, or organic fibers to improve the strength of the mix. The advantage of ultra-high performance concrete is that it does not require the presence of steel rebars to reinforce the structure. Ultra-high performance concrete has a compressive strength of up to 29,000 psi. What is it used for? Suitable for use in many industries, including domestic, agricultural, and commercial. Heavy-duty external paving and slabbing. Reinforced bases for commercial and agricultural buildings. Can withstand rubber-tired vehicles, loading and scraping. House garage floors contained embedded metal. Roller compacted concrete. This type of concrete requires the placing of concrete and compacting it with the help of road rollers. This type of concrete requires less cement comparatively, but it can provide higher density. This type of concrete is compacted heavily by rollers, making it very dense, strong, and easy to pour in vast quantities. It is also more cost-effective than other materials and uses less energy to produce than asphalt. What is it used for? Roller compacted concrete is commonly used for road and pavement construction instead of asphalt. Asphalt concrete. Surface roads, airports, parking lots, and embankment of dams require asphalt concrete. They are manufactured by mixing asphalt and aggregates. Reinforced concrete. Plain concrete does not have high tensile strength. Introducing reinforcement in the form of steel rods, bars, meshes or fibers can improve the overall strength of concrete. RCC has tremendous application in the construction of columns, ceilings, bridges, and other structures that require a high level of strength. Ready-mix concrete. It is concrete that is mixed at a central mixing plant and brought to the construction site in a ready-to-use condition. One should take care of the time required for transportation while using ready-mix concrete, as the mixture can harden if there is an undue delay. Ready-mix concrete is concrete that has been manufactured in a batch plant according to exact mix recipe, and then delivered to a work site via truck-mounted mixers. What is it used for? Ready-mix concrete is used in scenarios where getting the correct ratios of ingredients is vital and a very specific mix is required. It's also useful when sites are too small or busy for concrete to be mixed there and then, for example, a driveway. Stamped concrete. Driveways, patios, and interior floors that require an aesthetic appearance generally use stamped concrete. This architectural concrete allows the creation of realistic patterns such as natural stones, tiles and granites using professional stamping pads. Stamped concrete, often called textured or imprinted concrete, replicates stones, such as slate and flagstone, tile, brick, and even wood. The wide variety of pattern and color choices make it popular for beautifying patios, pool decks, driveways and more. Additionally, it's an affordable paving option that requires less maintenance than other materials. Self-consolidating concrete. As the name suggests, this type of concrete consolidates by its weight without entailing the use of vibration. Such a concrete mix has high workability. It is also known as self-compacting concrete. Given the addition of superplasticizers, self-compacting concrete has a high flow rate and can reach much higher strengths than basic mixes. As the name suggests, it can self-compact under its own weight, making it much easier to place. What is it used for? Thanks to its great strength, self-compacting concrete is often used for foundations or underground structures. Pre-stressed concrete. Megaconcrete projects use pre-stressed concrete units where the bars used in the concrete are stressed before the actual application of the service load. The construction process requires the tensioned bars to be placed firmly from each end of the unit. It makes the lower section of the structure stronger against the tension. Usually, the assembly of pre-stressing units takes place at the construction site. The construction of bridges, flyovers, etc. Precast concrete. Small units like concrete blocks, poles, concrete lintels, staircase units, and precast walls use precast concrete. The advantage of precast concrete is that it is manufactured according to individual specifications. The assembly of the units takes place at the construction site. Precast concrete is a form of concrete that is prepared, cast and cured off-site, usually in a controlled factory environment, using reusable molds. Precast concrete elements can be joined to other elements to form a complete structure. It is typically used for structural components such as wall panels, beams, columns, floors, staircases, pipes, tunnels, and so on. Applications. Reinforced concrete is usually used for structural systems due to its strength, durability, and affordability. Precast concrete is used in the following ways: to make beams, columns, floor slabs, foundations, and other structural members for buildings. To make wall or cladding panels for buildings. To make precast pre-stressed elements for buildings. To make components for infrastructure projects, elements such as bridge spans or metro line viaducts are often precast in a casting yard. To make products such as precast water tanks, septic tanks, drainage chambers, railway sleepers, floor beams, boundary walls, and water pipes. As it can be molded into any shape, it can also be used to create one-off unusual forms such as boats, sculptures and so on. Shotcrete concrete. Shotcrete concrete is different from other types of concrete in the way it is applied. It is shot into a structural frame with the help of a nozzle. The process involves shooting the concrete at a high air pressure that results in simultaneous placing and compacting. Shotcrete is usually an all-inclusive term for both the wet mix and dry mix versions. In pool construction, however, shotcrete refers to wet mix and gunite to dry mix. In this context, these terms are not interchangeable. Shotcrete is placed and compacted consolidated at the same time, due to the force with which it is ejected from the nozzle. It can be sprayed onto any type or shape of surface, including vertical or overhead areas. Lightweight concrete. Concrete having a density lower than 1,920 kilograms cubic meter is called lightweight concrete. Some of the typical aggregates used to manufacture lightweight concrete are pumice, scoria, and perlites. It is used in applications such as the construction of long-span bridge decks and their building blocks. The benefits of using lightweight aggregate concrete include reduction in dead loads, making savings in foundations and reinforcement. Improved thermal properties. Improved fire resistance. Savings in transporting and handling precast units on site. Reduction in formwork and propping. High-density concrete, also known as heavyweight concrete. This type of concrete has a density in the range of 3,000 to 4,000 kilograms cubic meter. High-density concrete is prepared using heavyweight aggregates such as barytes. Some common applications of this type of concrete include the construction of atomic power plants, where ensuring high resistance against any kind of radiation leak is of utmost importance. Polymer concrete. In polymer concrete, the aggregates bond with the polymer rather than cement, which in turn helps in reducing the volume of voids in the aggregates. There are three types of polymer concrete, which include polymer impregnated concrete, partially impregnated polymer concrete, and polymer cement concrete. Polymer concrete is a type of concrete that uses polymer to replace lime-type cements as a binder. Air-entrained concrete. It is a special type of concrete where air, gas, or foam is purposely infused in up to 6% of the concrete. Air-entrained concrete contains billions of microscopic air cells per cubic foot. These air pockets relieve internal pressure on the concrete by providing tiny chambers for water to expand into when it freezes. The amount of entrained air is usually between 4 and 7% of the volume of the concrete, but may be varied as required by special conditions. Limecrete. Limecrete involves the use of limestone instead of cement in the preparation process. Limecrete is a combination of natural hydraulic lime and lightweight aggregates such as sharp sand or glass fibers. It has applications in the construction of floors, domes, and vaults. Pervious concrete. Pervious concrete, also called porous concrete, permeable concrete, no fines concrete and porous pavement, is a special type of concrete with a high porosity used for concrete flatwork applications that allows water from precipitation and other sources to pass directly through, thereby reducing the runoff from a site and allowing groundwater recharge. Pavements and driveways use pervious or permeable concrete as it allows storm water to percolate into the ground. Such concrete can solve drainage issues. Glass concrete. This modern concrete uses recycled glass as aggregates to increase the aesthetic appeal of the structure. Besides being durable, this concrete provides thermal insulation. Glass fiber reinforced concrete consists of high-strength alkali-resistant glass fiber embedded in a concrete. The use of crushed waste glass as aggregate in concrete is problematic because of the chemical reaction between the alkali in the cement and the silica in the glass. Vacuum concrete. This concrete mix contains a higher proportion of water. Their preparation process involves suction of excess water using a vacuum pump without waiting for the concrete mixture to set. This process hastens the strengthening period of the structure from 28 days to around 10 days. Vacuum concrete is the type of concrete in which the excess water is removed for improving concrete strength. The water is removed by use of vacuum mats connected to a vacuum pump. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.